This isn't right. Okay, here we go. Chapter 2. So chapter 2, we are going to talk all about functions. And we actually do functions all the way through first semester until we get halfway through second semester, and then we talk about things that are not functions. And it gets pretty difficult. That's chapter 10, everyone's favorite chapter. All right, so here we go. Lesson 2-1. We're going to talk about relations and functions today. Relations, are they functions? So not everything is a function. We're going to find out what makes it a function, all that good stuff. Okay, so here's our first part. We're going to do a little introduction into what is a relation, what is a function. So a relation is just basically just a set of output and input values. Okay? There's no rules on relations. Okay? You can have a relationship with this person and your mom and your uncle and da-da-da. There's no rules. They're just like they're relations. But if you're a function, then there's a specific relation, type of relation. So I'm going to show you 4 ways to show a relation between two numbers. You can write numbers as points. Okay? You can write numbers as points. And so points are always x, comma, y. Some people call them ordered pairs because order matters, right? If I tell you to plot the point on a Cartesian plane, on an xy axis, and I say plot the point 2, 3, that's different than 3, 2, right? Yeah, you should know that. Okay, so let me go ahead and write this relation of numbers. -3 goes with 4. 3 goes with -1, and 4 goes with -1. Okay, that's a relation of points, 3 points, and that's how they are written when you write them as ordered pairs. Now, the next one is called a mapping diagram. You can just call it mapping. Mapping's probably the least used, but some people like to see it as a mapping because they're very visual learners. They like to see things. So if you have numbers over here, I'm just going to use these same numbers every time. So -3, 3, and 4. And then on this side, I have 4 and -1. Well, -3 goes with 4, okay? And 3 goes with -1, and 4 goes with -1. And that's okay. There you go. And that's a mapping diagram with a bunch of arrows and some weird things. All right, the next one, there's 4 of them. The next one is to write them in table form. Table form. By the way, make sure you're getting that calculator. If you haven't already, the graphing calculator, you need it. We're gonna be using it very soon. A table will look like this. You can call it an XY table, a T-chart, and it looks like this. If X is -3, then for these points it matches with 4. 3 matches to -1, and 4 matches to -1. So that's 3 ways. So we have points, mapping, table. And then finally, our last way to represent a relation that we're going to do is by its graph. And you haven't graphed in a while, and usually people don't like to graph. It's because it takes time and you have to think. I have graph paper over there in the bin if you ever need any. So that's for you. And so you graph, right? This is the x-axis is this one. And the y-axis is this way, okay? This is quadrant 1. This is quadrant 2. It's really weird. It goes counterclockwise. You'll find out why when you take calculus. Or no, trig. You'll find out when we take trig. You're not taking trig? Ram or ham next year? No? Oh, you should rethink that. All right, then we're going to go -3, 4. So -3, +4. So -3 on the x-axis, +4 on the y. You know how to plot points, right? Yeah? My 6th grader, he's plotting points. I didn't know they did that in 6th grade. I really like helping him with his math. I do. I know, I'm such a nerd. They're doing ratios, really hard stuff. So 3, -1, And then, that's not 3, -1, is it? 3, -1 is right here. And then 4, -1. So all 4 of these things are exactly the same thing. It's showing you the relation between these 3 points, but in different ways. I kind of like points the best, just ordered pairs. All right, so now for these, we are going to have something called domain and range. Yes, they always kind of go together, don't they? Domain and range. These are very big topics in HAM, on Honors Advanced Math, the class I teach in the morning. Really big topics in there. All right, so domain are going to be the x values. The x values. For a function, a lot of times they are called the input, and they are the independent value, independent numbers. Independent, that's a long word. Independent, okay? So range is going to be all the opposites of that, pretty much. So instead of the x values, they are the y values. Instead of input, they are output. And instead of independent, they are dependent. Exactly. Have you ever made a t-chart and then your teacher said, you go ahead and choose the x numbers? That's independent. You get to pick them from anywhere. But once you plug them into the function she gave you or he gave you, those depend on what you've chosen for x. So that's domain and range. That's going to be really important. So up here, number 1. What is the domain and what is the range of this example I gave up above? So what is the domain? What is the range? Now, if you ever get confused on, oh, what is it? Look back at its definition. The definition tells you what it is. The domain are the x values. So when you look up here at this example I gave you, what are the x values? Perfect. -3, 3, and 4. And that's the domain. The x values that were in that problem. And what is the range? 4 and -1. Perfect. Okay, so we're getting there. We're now going to say what a function is, finally. And why are they so important? Functions happen a lot. Yeah.
So you don't have to put -1 twice?
Nope. You can. It's not wrong. Yeah. Oh, if it was wrong? Yeah. No, it's not wrong. You just don't have to. It's redundant. It's redundant. It's redundant. Thanks. I'm here every day. All right, here we go. Function. So what is a function? Well, it means that each element in the domain, corresponds, it's kind of a fancy word, like matches up with, corresponds with exactly 1 in the range. Okay? Because they're going to ask you, and I'm going to ask you, is this relation a function? It's a yes or no answer. You get a 50-50 shot at getting it right, but you want to get it right. Each element in the domain corresponds with exactly 1 in the range. Okay? So what that means is this. If 3 is matching up with 4, then 3 can't match up with 5 also. Okay? You can't do that. This would be no way. Not going to happen. I like to explain it like this. Let's say that I have this machine right here. Kind of a weird looking machine. And let's say that this machine is the squaring machine. Okay? Yeah.
That says 1, right?
Where? 1.
Exactly.
Oh, yeah. Sorry. 1. Yeah. It's the pen's fault, not mine. So this is some weird function machine, okay? And let's say that I decide to pick x equals 3, and I plug it in. Beep, boop, beep, boop. Something happens in the function machine. It's all like working. The gears are in there. They're all working. And then out spits 9. Okay? Great. If I plug in -3, out spits 9, that's okay. But if I plug in 3 again and out spits 10, there's something wrong, right? I can't plug a number in and get 2 separate answers for y. It's just not going to happen. So what I like to do is this. The x values cannot repeat. okay? The y values can. It's fine. 3 goes in, comes out 9. Negative 3 comes out 9, but they only come out one answer. You cannot have an x value come out as 2 separate answers. X values cannot repeat. That's going to be a really easy way to tell if it's a function. The other way, because there's 2 ways, the other way is by using the VLT. You thought I said BLT. It's a delicious sandwich made with bacon. This is a VLT, which is totally different. No, it's not venison or veal. Do you like venison? Do you like veal? The vertical line test is what it is. Have you ever heard of that before? I think so. Yes. Oh, yes, you mean. Yes, the vertical line test. In order to be a function, any vertical line can only touch once. Okay? Only touch once. That's an O. If any vertical line that you can imagine on the graph touches more than one spot, it's not a function. You remember that? You don't like this? You'll like it because guess what? The first time you learn something, it's hard because it's brand new. You've already seen it. So now you're kind of relearning it and you're going, whoa, I'm 2 years older than I was when I learned this stuff and smarter. And your brain can handle it. It can. All right, vertical line test. So here we go. Number 2. Yes or no? Is it a function? And I'm going to show you a bunch of them. Is it a function? Letter A. All right, let's do this one. I'm going to have a set of points here. 5, 3, 6, 2, 7, 1, 7, 0. 4 points. Okay? Is that a function? No. No, it's not. This is not a function. The only reason why it breaks the function rule is right here. 7 went into this function, came out 1, and then 7 went back in and came out 0. No, not possible. It's not a function. Okay, how about something that looks like this? It's just a line, a slanted line. Okay? Is that a function? Yes. Okay, so I did something different for both of these. This was a list of points, so I looked at the x values to see what was going on. This is a graph. So what I did in my mind is I took an imaginary vertical line and I just kind of drew some in my mind like that, and it only touched once. Yeah?
Say you have 5, 3, and then could you have like 3, 2? Like
Sure.
For the next one, like you can't just, it can't be in the same spot.
Yeah, the x values cannot repeat. So
okay.
If you had 6, 2, and then you also have like 8, 2, that's fine. Y can repeat.
Oh.
But the x's can't match up with 2. So 7 matches to 1, then it's with 1 forever. 7 matches to 0, that's a problem. But the y's, it doesn't matter.
Okay, so you could switch it like 6,
Yeah.
2 and 2, 6.
Yeah. So let me show you an example right here, a graphical example. Suppose that we have this graph. We're going to study these in depth too. What is that called? Do you remember what that's called? Parabola. That's a parabola. Okay. If I go to a parabola and I look at, say, this point, let's call it 3. Let's say that's the point 3, 9. Over here, what's that point? Negative 3, 9. Yeah. That's okay. Is this a function? Draw some vertical lines. Sure, it's a function. Okay, vertical lines touch one spot. It's okay for the y's to match up, but it's not okay for the x's. So we're going to study lines. We're going to study parabolas. In second semester, we're going to get to non-functions, and we're going to study something like this. This is chapter 10. Circles. We're going to study circles and ellipses and hyperbolas and all these fun things. Are they functions, though? Nope. I drew a vertical line, and that vertical line touched twice. Do you see this x right here? It has 2 y values. It has that y value, and it has that y value, and you're not allowed to have x repeat like that. So is this a function? No. Are you going to be in here or next door next semester? Do you know? In here? In here? In here? In here? Next door? In here? Okay. I'll try and keep you. I'm going to keep you. You're all really, really nice. I don't dislike any of you yet. Okay, here we go. Letter E. Letter E. Ooh, here's something we're going to study next semester. Exponential decay. Town's population gets a disease and they're dying. It's very exciting stuff. It really is. But is that a function?
No.
Oh, no. It actually doesn't go straight up and down. Okay, yeah, it is a function. So it passes the vertical line test. This would be yes, too. So I use the vertical line test a lot to determine if something is a function. Oh, here's a good question for you. You know how we did lines right here? Are all lines functions? Are all lines functions? No. There's one special line that is not a function. Do you know what that is? Vertical line. A vertical line is not a function. All the rest of them are. Yeah?
Is C or D no?
D is no. Oh, C is yes. Sorry. So parabolas are functions unless they get turned sideways, then they're not. Okay? Lines are functions if it's not vertical line. This exponential is a function. We're going to study all this stuff. Aren't you so excited? You should be. Okay. You're pumped up. It's almost like your favorite series just came out with season 2 and you're ready to watch it. Part B. Here we go. Function notation. What are you watching over there? You watching something? Function notation. Nope, not me. You're not playing Fortnite, are you? No. Okay. My son played Fortnite this weekend a lot. All right, function notation. Here we go. Y equals 3x plus 2. Okay, there's a line. We're going to study that kind of thing coming up on the block tomorrow, Thursday. And y equals 3x plus 2. Now, instead of y equals 3x plus 2, they're going to change this to what's called function notation. So instead of y, they replace it with f of x. Do you remember that? Most people, when they learn that, they're like, what? Why did you just make that so complicated? It's just saying that this is a function of x. Instead of y equals, it's now f of x. Okay? So what we're going to do is we're going to, what number are we on, like 3 or 4? 3. I know we had like A, B, C, D, E. That's a lot. We're going to evaluate. So let's say we had this function, f of x equals 3x plus 2. We're going to find out what f of 5 is. What is f of 5? Do you remember how to do this? It's like a function machine again. 5 is going into this function. 5 is going in for x, and so you're going to replace x with 5 now. And that is your input. 5 goes into the function, beep, boop, and then it spits out 17. Is it 17? Yeah, 17. I kind of yelled that. 17. There you go. And so what happens is this is the ordered pair 5, 17. Yes. You try one. You try one. Yeah.
Why didn't we put 5 in there?
Because they told us to. It's some random, independent number. How about a different number? What's your favorite number? Pi. Okay, what's your favorite whole number? 1,005. Okay, let's do that. F of 1,005. Like, dang it. You need a calculator? Do you need your calculator for this? Maybe. No? No? You can do that? So now we're going to plug in 1,005. But it's random. It's just an independent number. We're going to do 3 times 1,005 plus 2. What'd you get? 3,017. Perfect. The year I was born. No. Wait. Never mind. That doesn't make any sense. Okay. Now, last one. Number 4. And it's a real-world model. Okay? So, tickets. Let's say that you're in charge of buying the tickets for a concert that you're going to go to. Have you been to a concert yet? What have you seen? Wow, I didn't go to my first concert till I was 19 years old. Yep, I saw Green Day.
Yeah, Green Day.
I know, yeah, they were super young band that I wanted to go see. Yeah, 8. Wow. All right, so tickets for a concert, and you're gonna buy this. You're gonna buy all the tickets for your pals, and the tickets cost you $35. One time I was buying tickets to a Kings game on SeatGeek, and I'm buying 2 tickets, but it charged me for 10. Yeah, and it was like $1,000. Yeah, it charged my credit card, and I was like, what? So it says all sales are final. So I'm like, no. I call up, and the guy's like, yeah, it's 10 tickets you purchased. And I'm like, no, I put in 2. I put in 2. And he's like, I'm sorry, I can't do anything. So I start crying, and I'm like, I don't even have 10 friends. And then he felt so bad for me. He got his manager on the line, and then they took off the stuff. Anyways, it was really good. Like, I don't even like 10 people. It's true. Okay, anyways, so tickets are $35, super cheap. And then they charge you a handling fee. I recorded all of that. Oops. Handling fee of $2.50. It's just a flat rate. It's not per ticket. Normally it's per ticket. That's crazy. $2.50 flat rate, okay? So what we're going to do is we're going to model this as a function. So letter A, we're going to model the cost, and then they're going to call it C of T tickets. You know, if you don't like their variables, it's okay. I'm not picky. If you want to use X and Y all the time because you like it, that's fine. But this time they wanted us to use C and T, so I'll go ahead and do it. So model the cost C of T tickets as a function. So here we go. The cost of T tickets, C of T, equals, so it's $35 per ticket with a handling fee of $2.50. So that would be 35T plus $2.50. Okay? And we did function models in our last chapter, but we didn't write it in function notation. We just kind of wrote it as C equals. So this is function notation. So let's say you have 10 friends, because I bet you do, and you're going to take those 10 friends to a concert. Now, they're going to pay you back, but you have to pay for all the tickets so you can all sit together. You better make sure your friends pay you back for that. So how much would it cost you? What are they going to charge your credit card to take 10 friends on this trip to go see your favorite band? It would be C of T equals, and then you plug in 10 for 10 tickets, right? I mean, that should make a lot of sense to you. $2.50. And so that would be, what is that? $352.50. Whew, it's a lot of money. They better pay you back.